Greetings, like we are a team of 4 from NIT Calicut. So first let me introduce myself. Myself Karthik Jaras. I am a third year mechanical engineering student and I am the team lead of this group.
Myself, I am Shirin Fazil. I am third year chemical engineering student and my main contribution is in electronics and PCB designing.
Myself Nikita, third year mechanical, and what I did major was mechanical design.
I'm Aftab Ahmad from chemical third year and I was mostly involved in coding and programming.
So when we moving to the main highlights of our robot, the two main highlights are the mechanical design and the motor calibration part. We have tried to fabricate the board in a unique design with a unique design, and we have tried to manufacture it using two modern technologies, laser printing and 3D printing. And when we come to the motor calibration part, the different motors were rotating at different speeds in with the same PWM. So we tried to calibrate the all the motors in such a way that they will rotate at same RPM with same PWM.
Talking about the difficulties that we face, one issue is the space constraint. So, incorporating everything, including the battery and the PCB design, was a bit difficult of task. Further talking about the electronic part.
And like in PWM calibration, like we have used an encoders to calibrate the like motors, and with the values of like RPM values and the PWM values, we have plotted it and we have normalized that.
And we faced an issue where the static IP was not remaining the same while connecting to micro ROS. So we utilized the laptop hotspot as a access point and fixed a static IP for the laptop using a different Wi-Fi hotspot program.
So this is the theme run for HB 11441 task 6 theme run. So we are initially we are starting the bots one by one through the terminal. So as you can see, the first bot has started moving. Second bot will also start, and then soon the third bot will start. We had already started the camera and visualization node and the pen feedback nodes. So the bots are yet to reach the first point, I guess. So the first bot has reached its initial point. There is some amount of overshoot in those regions because it is moving from like large error. It is trying to minimize a large error. We had tried to implement a way that the bot will always move tangent to that curve, but it does not perform perfectly in every sense, in every situation. As you can see, the first curve it has navigated fairly well, even though there was some zigzag motion initially. The second bot also has started and finished like half of a single petal. Now the third bot has been started and it will start moving. So we tried both the approach of having dynamic way of avoiding collisions and like hard coding this path that is more that avoids collisions. So this is a path that we found was more effective than the dynamic one, which would make the runtime much longer. the bots have little bit trouble navigating the ends of the petals because the density of the points is greater over there, and since there is like a rotation movement over there, it finds it a little bit difficult to uh, navigate those curves. But in the more straight sections, it's able to follow the line somewhat. As you saw earlier, I guess when the bot is moving in reverse, it has some tendency of oscillation. But in when it is moving in a straight forward direction, pointing towards the direction of movement, it is gives more straight curves. This is because we have found some difficulty uh, in tuning the theta controller, so like controlling the theta angle. But so that's the reason why we see like this kind of oscillations. But the XY controllers work fairly well. So I guess the first two bots are nearing the end of their run. Once the bot has finished their run, both of the bots will try and move out of the uh, arena so as to not interfere with the run of the third bot, or like the first bot, for not to interfere with the other bots. So like once the first one is done, it will leave the arena. As you can see, it's leaving the arena now. It is supposed to leave in that corner through the corners. So once the second bot is also completed with its uh, path, it will leave the arena. Since we have normalized normalized the tuning of the motors, we have noticed that uh, the minimum speed of some of the motors are not so good. So we face the issue of where the bot will stall because the error becomes too less. Because that operating range for that motor is very less for us once we finished like normalizing that three motors together. So that's why we had to uh, give a small push to the bot in between, as we saw over there for the bot that went last, the bot number one. So far the second bot, which is a red bot, has completed its path, and the bot number three is going to complete its path, and bot number one is yet to finish. There is a small collision. We have removed the dynamic collision functionality because it was increasing the runtime a lot. So even and we have planned this path, but because of the variation in the time it takes, sometimes small collisions will happen. But often it is not too problematic towards the run. I can see that the bot one's entire path is completed and it has left the arena through the other corner. So we only have one bot left within the arena and a little bit of the petal left, of the last petal left. So I guess the run has been completed almost. It's done. Basically, it's done now. Yeah, that's it. Thank you. Thank you. the we are stopping the evaluator now as the third bot is leaving, and this is the RQT graph of the entire like ROS system. So yeah, that's it. We got a error value of 5.65 and a runtime for 6 minutes 45 seconds. Thank you.